Hello.
Nancy sir, shall we start?
Nancy sir, am I audible?
Yes, sir.
Okay.
Am I audible?
Yes, sir. Yes, sir. Yes, sir. Audible, sir.
Okay.
Can we start, sir?
Oh, yes, sir.
Okay. Okay. Good evening to all. Our next session is on embedded machine learning applications. The session will be handled by Mr. Sutish V.S., who is currently working as research assistant at International Center for Free and Open Source Software, ICFOS. Mr. Sutish completed his bachelor degree from KMP College of Engineering, and he completed his PG diploma in Advanced Embedded System Design from Keltron Knowledge Service Group. He acquired various certifications and licenses in machine learning and embedded system design. He also worked as embedded system consultant at Metro Innovations and as an academic executive at Keltron Knowledge Service Group. His major areas of interest are machine learning and artificial intelligence. On behalf of entire Electronics Department of LBS College of Engineering, Kasaragod, I welcome you, sir.
Thank you.
Over to you, sir.
Okay. I think the research is already conducted the session on edge analytics and IoT, but I would like to start from there also. In my session, I like to present about this is my agenda, because if you it is basically on the application. I would like to present the topic about on the application, how the edge analytics works, how we can do the edge analytics devices, and what the device is available and the applications like that. So I will start from the IoT, even if already is completed, because that the better to I explain how it's work. So first we go to the IoT section. You already know that everything is IoT. Currently today's the IoT boom is happening, because every sensor, every device is connected to internet, or anything is connected to internet. So the two scenarios is here. One is the internet is already connected devices, and the things which not connected. If the IoT device number of sensors increases, number of device increases, the data is also increases. So it's possible to conject the cloud. All the data is sent to.
Voice is not clear.
I am not audible, I think. Hello. Am I clear?
Audible.
Okay. Okay. Can I continue? I think it's voice like clear.
Yes, sir. Yes, sir. Clear.
Okay. If we already Lexar or any other persons told that the number of sensors or devices increases, the data coming from the IoT devices increases. So such a case, we need to manage the very large scale infra to manage the data. That's the cloud. The cloud data management is not easy, but the big companies are doing that thing. In our cases, in open source thing view, if you need to create an application in IoT in your home or in your organization or anywhere else, you can choose one thing. One, you can choose the privately available cloud thing, or you can create your own cloud. That own cloud is more difficult, because it needs some idea about your server and server architecture, etc. So that also is problem. Moving to the edge analytics, we are cloud computing industry. Before going to the edge analytics, we said about the cloud computing. It is need to it's an application. If you have an IoT application, you need to create a device application, any application on IoT device, which need to work in very fast. It need to take a very fast decision. If you use a cloud scenario, the speed and time to react is very slow. If you need to decide any decision in your device, you need to send the data into your cloud, then get back to the data from the cloud to device. Then only the complete cycle is completed for taking a decision. So that the case the actuation is delayed. It may case the some application not work correctly. That next one is connectivity issue. The connectivity issue is if the IoT device only work with when internet is available or any communication is available. If you need to decide the actuation is needed in your device, that IoT device that need to process the data in cloud. If there is connection, the device it may not be work. That the next problem. The another problem is privacy. The privacy is that if you are sending your data into the cloud, it may be hacked, or someone else can be taken your data. It will make a problem. That's the privacy concern. So also there is if you are using cloud computing there. Even though the sensor, the main problem is not all other than it is all if we are using many sensors in our IoT device. We are using temperature, humidity in your device, like sensor, any device, any sensors in your IoT application. But the problem is even the raw data given by the sensor is a huge one. The raw data is a huge one, but we are not able to send the data into your cloud or any such sensor, because in case of IoT there is a new two section, because low power device and the high power device. In high power cases it's not a problem, because we are, for example, we are using Wi-Fi or any Bluetooth like communication device, short distance device, then it is not a problem, because already we have a large bandwidth. For 5G case it's also not a problem. But in case of lower bandwidth case, lower bandwidth means less than 3G case. So we already need a smaller data to streaming out the server. We need only a lesser communication like LoRaWAN devices. So if in LoRaWAN cases there is a problem with the duty cycle limitations. The duty cycle limitations cases we cannot able to send the complete data into your cloud or any servers. That cases we need to discard the 99% of sensor data due to that thing. Also the cost and the power constraint, because for a low power device we need to maintain the battery power in a long time. But that cases we need to go to the sleep or rest time. Only when the data is entered, then only the device is active. In that case, the fully sensor data is discarded. Only the part of the data is entered. That's the next one main problem in cloud computing users. So moving from this, we are completely ignoring the cloud section. While we moving to the edge analytics, already started, but the applications are needed for IoT analytics in IoT scenarios. But I am telling about the structure, what the IoT edge architecture is relaying. That is, first one is any device that can be an edge device. It's a normally IoT device containing sensor devices, controllers, etc. And the computing part is the data element that analyzes the data, analyze and transform the data into a meaningful words. And the cloud computing part is the internet gateways. Currently, it's a gateway or any switches or any routers that your data is forwarded to any sections. And the data ingestion analysis. The data ingestion analysis is the part we are going to store the data. All your sensor data is going to be stored there. Then the application. Using this data, you can analyze and predict the correct information from the data and use into an application. The people process are the users that can use these applications. From it is first it's an edge device. The edge device is basically a control device that connected to any communication protocol like LoRaWAN, Bluetooth, low-energy Bluetooth, communication devices that capable of only processing a less amount of data at a time. the second scenario, we are dividing the IoT architecture into three sections. It's the edge computing devices. Second is fog computing devices and cloud computing devices. We are going to discuss in edge computing, but I want to tell about what the three of things. The edge computing devices are the devices which the computing element and the edge elements are combined, and it is a simple one devices. So we can process the data within the sensor origination. That's when the temperature sensor senses the temperature. Within the sensor, we can sense the data, and we can analyze the data within the controller device or IoT device. Next part is a fog computing devices. Fog computing devices is in between the cloud and edge. That is even edge is a gateway or any more power than edge, less power than cloud computing. So first we need to sense the process any data. We need to sense the data in edge sections that not a low power devices. It is sent it to a central devices. That's the gateway. When the gateway receives the data, it get analyze the data. Then after the meaningful data is get from the gateway, that will be stored into the cloud, or that moving to the big data analysis. That is the basic IoT architecture commonly we are going to use. So next one is edge analytics. Already you know what the edge analytics. The edge analytics is automated analytic computation of edge data sensor controller or device level. If we are going to use any IoT device, the edge analytics it will be in the device itself. So we analyze the data generated nearby the source. Thus, the latency. We already told that the computing have a latency for decision making process. So it will be decreased. Also power scalability, because if you are using cloud computing, we need to power edge device as well as the cloud computing devices. So we need a more power. Even the edge device can capable of computing some process. Even that power is lost. So power scalability is one thing. The subset of data we can use the maximum power of utilization in your edge sections. Also, the next one is the network cost, because we know that the bandwidth is one of thing in network. If the number of data increases, the bandwidth need to send to the cloud is also increases. So we need to reduce the data size to manage the bandwidth is minimum. So we need also it capable of reduce your network cost. Also, next one of the main thing another one is the privacy, because we are not sending any raw data or any sensor data that sensitive to user. That already processed in your device. So we don't need to worry about your data privacy, because already data is processed. So meaningful data was sent to the user level. So it is also a good to maintain the privacy of IoT devices. Also, okay, that's the basic thing in analytics. Anything more thing I am not going to discussing. Next, I am going to talk about the application. Where are the analytics applications happening? So potential areas, commonly used areas is smart surveillance, predictive maintenance, edge optimization, and the smart meters, agriculture, and healthcare. So we discuss each of one and each of user applications that already analytics are currently used in industries. So first is the smart surveillance. So already everyone knows that there is some use cases are there. That's smart forest. In smart forest, there is I have listed three applications. That is a fire detection, accuracy properties, and animal activity detection. In fire detection, we already know not in our India, but in outside countries, most of the fire detection is done by this analytics. Also, accuracy properties mainly for the found the tree cutting and some other purpose, human activity purpose in forest areas. Also, animal activity detected for a animal detection like elephant is coming, or elephant is coming to our people's sides like that. Also, that's another one of the 3 user cases listed. And next one is the smart CCTV. That's already everyone is known because we are currently using the traffic management, name road detection, or person tracking and the face detection and the social distancing. Already everyone is known that thing. The next one is predictive maintenance. The predictive maintenance is one of the major area in industry that analytics is performed. That edge devices are it's smart devices because everyone knows smart devices containing some battery sensors on functionalities, some additional functionality. So edge analytics may be commonly used for the battery manager. For if you are using your electrical car, then there will be a battery management system (BMS). So BMS with the AI, that's the new thing we are going to come in throughout. So AI may be useful for the battery management because how many the user behavior, that battery is discharging, or battery temperature condition, or any other parameters are detected. Then they decide what the current need to the battery charge in a particular time. It's normally BMS have a constant current charging methods. So when the AI is included, the only charge needed to the battery is provided because that they need the battery make more lifespan. The lifespan of battery can be increased. Also, the next one is a sensor for detection. The sensor board is already, I think, the costly cars are already available with that features because even any sensor is faulted, that will be notified to the user or company. That can be done by your analytics devices. Also, functionality management is any functionality is working. It's normally called anomaly based detection. So if any functionality problem is detected, then you can use these same analytics to work out manage the functionality management. Also, the next section is the smart building. So in smart building, the main thing is like that. So that can also be done in analytics. The glass quality assessment is, I think, it is one of the major areas not in our India because in outside countries, most of the office rooms and or any structural building is main glass is the main part. So they used to detect the glass quality by using some sensor methods. So that's also a genetics application. As the surface crack detection is the next one. It's already or structural in. It is a sub application of structural monitoring, but it's also an application. And next one is the disaster management. That's already, I think, someone are doing that thing in Kerala. Yeah, I think it's in Mona. Disaster management, we already faced some of the areas. Landslide is already when we are heavy rain is occurred, but that can be managed and detected without any internet because, for example, we are trying to implement it in Mona. We know that it's a hill area. The range of network can be damaged within less than a meter if there are any high rain or any problems occur. So, such a case, we can use this type of analytics to predict the landslide predictions to make the device work, even though the communication is not available. Okay. The next cases is energy optimization and smart meters. In energy, there are 2 sections mainly with smart water meters and the energy meters. The first one is the leakage detection and over-usage detection. Leakage detection can be done by the detecting the anomaly in your water usage or water usage because even though currently we are available in leakage detection water meter, it is purely based on decision-based water meters. But in near future, we can use the genetics to predict the leakage detection and the overusage detection and block the water if you are using the water more than your fixed level. So that's the water meter applications. The next one is the smart energy meters. So energy meters commonly we are using for the load detection and the short circuit detection and earth leakage detection and thunder detection. The four of another commonly used for circuit-based detection systems already is all available. But even if we are using the IoT-enabled energy meters, we can more easily create the energy easily better energy meter with the AI. So that's one of the major area in genetics. In agriculture, commonly we are using the greenhouse automation because we need, if some culture need a specific environment to work out. So we need adjust the environment depending on the need of your culture. Or the plant disease detection, that it's a image-based detection that we can detect the plant disease in even if though it's not happened. And the token analysis is simply is a funny application that the plant need talk yourself to water, give me water, like commands. You can create that like application using genetics. And garbage collection and environmental gas detection and beam monitor. Beam monitor means in beam monitor we can monitor the activity of bee. This is queuing is present or in your bee. So that one of the agriculture based use cases. The next one is the smart health. It is a more actively working use cases because human activity recognition, eclipses is a recognition, heartbeat anomaly detection, cough detection. The common use cases already everyone is not going to. Okay. That are some use cases we are going commonly used or commonly we can do in genetics. So we need to create an edge device. That's our aim, today's aim. We need to create an edge device. We need to work out your data with the edge. That's our aim. So we need to create an edge device. What the edge device? We already know that the data is there present in device. That analyze and give the decision that with depending on your data, what the data is inputted. So. First thing is, if even though it's edge genetics, we need to, there is a part of machine learning process is there. Everything is machine learning process. So normally it's a two-phase process because first one is a training phase and the second one is interface phase. The data you are collected, if you are creating your edge analytics device, you first need to create data. You need to create a sensor data that you need to want to output. For example, if you are creating the season detection device, you need to create the ECG raw data that already are happening. The CSS is happening or CSS not happening time period data. So that data need to be used to create the training the model. The model is trained using the commonly used algorithms. Already everyone is know the machine learning algorithms, what are the algorithms. So the training models are created using some of tools that we can currently already available. So we can train the model, test the model, and adjust the parameter to better one. It is a normal machine learning process that we can do in your normal system or in computer system or GPU like systems. That is because we already have a large number of data. Large number of data need a large processing power. So we need a large high processing power system to do the training phase. After that, we create a model. We can convert into interface phase. Interface phase is deploying the model. The deploying model in normal model we can use any code, any Python or C or any code to deploy to your system or server that create an endpoint to predict or any classification actions. But in case of edge genetics, we need to not directly able to deploy your model into your device because we know that the edge devices are not a high power device because low power device also it's a low processing powers. So even model is available, we need to quantize your model, because even if you are creating a model in your system, it will be a floating point numbers. Everything is a floating point number, so we need to quantize to the floating point number into a fixed numbers. That's called the quantization. So this process can done using have many tools we can discuss later. So this is the first thing, you need to model the weight into quantization thing. Then we need to you can convert this model into a CRA or any code based models. So for commonly we use C program to convert a library. We need to create a library in C program after converting a model into a quantization model. This model is converted into a library based codes. That model become code. Then this code is compiled with our controller code. Then it will be deployed into our agentic system. Okay, the implementation is simple. The first one is we need to find out what is the edge devices. Then we need to collect the data, train the data, build the model, convert model into library, then make a framework and build into your system. Then the next will be the sense data, live data will be worked for your agentics. Okay, that's the main working when we are going to work with that thing. The next one is how we can use what are the tools available for your agentics applications. What the tools I can use. These all things are open source based tools. So your data in your site, so you can download from internet and keep your data in your system, train in your system, create a model, then you can deploy this model, only this model to your agentics or any production device. So TinyML framework, because TinyML is a name suggested by some organization or group of people created a TinyML organization that looking forward with the agentics based devices. So in TinyML, the following are the main tools we are commonly using. TensorFlow Lite, TensorFlow is already everyone knows now, because one of the major machine learning framework is the TensorFlow. The TensorFlow Lite is the same one, but it's a TensorFlow Lite for microcontrollers based one. And EMLEarn, it is a specific, it is a Git repo, so it can use for some, not all machine learning process, because some of the processes like random forest and tree classifiers, and microML for SVM, SVC, and PC, and then mu tensor. That's a new tensor, not a U tensor, new tensor that commonly used for converting your model into machine learning codes or embedded codes. That's embedded codes. So embedded learning libraries, that's the DeepC, is like a TensorFlow library that can compile and interface framework you can use. And the easiest, those are the code-based ones. All other are code-based ones, because you need to write your own code, you need to write the code, you need to create the code, you need to create your model in all things you need to yourself. But other than that, you can easily deploy. Even if you know how to code, you are not any ML developer or any machine learning expert, you can create the agentics devices. So that case we can commonly use the two platforms available there. That's the EdgeImpulse devices and the Canvas devices. The EdgeImpulse device is a very simple and easy one, and the Canvas is also already pre-trained models are there. You can use the model to deploy in your system. Okay, the next one is the EdgeImpulse device. We go through before going to EdgeImpulse. I like to what are the devices can use, because the edge devices are not a normal IoT device, because it needs some more power than any IoT device. Because if you are sensing the temperature, you can use a Almeca 32, because it is a cheapest one sensor, or Arduino, It's a cheapest one board that can use to sense and process and send data into a cloud. Because if you need to create any device that need to process your data or machine learning model process data, it has some limitations. So we need to use some devices like this one, Arduino Nano BLE. It's already available because this is a shorter listed one because there is many devices available in your market. But these are the potentially one already I see in market. So Arduino Nano BLE, ESP32 CAM, OpenMV CAM, we can discuss each of one. Okay, the next one is Arduino Nano 33 BLE SAS. This is the simplest one. It's about 2000 rupees device. It's consisting of these features. The operating voltage is 3.3 voltage and it's an NRF of 52840 base one. And input voltage is limited to 21 volt. Then the pin voltage output is 50 milliampere. Specific spec as there you can read out. The next one is ESP32 CAM Wi-Fi module. You can if you are interested in computer vision, it is the cheapest one. Cheapest modules available for making edge analytics based on computer because it is the cheapest one. It's around less than 1000 rupees. So it can use to create the edge analytics device that depending on the computer vision based devices like face recognition, people detection, or mask detection like projects. You can use that one. Next one is a higher one, more than high power than ESP32 CAM, and it's too much costly. But in this case, you can use this to create almost all the vision-based projects. Also, with the camera module, there is many different type of camera modules available because if you need infrared-based cameras, you can fix in pair the infrared camera fix into this board. That can be easy to work with that based applications. So this is the one of next one. The next one is Protena X7. It's higher than the Arduino Nano. Arduino Nano is only a basic one. Arduino Protena X7 is a higher version of Arduino Nano. So it's capable of working with the embedded Linux. So it's an ARM-based processor. So the heavy processing is available there. So you can have more than high-powered analytics can be done using this board. Also, STM32L for discovery board. This is a basically developer board. So it's similar to that of Protena one because the controllers specifications are some are equal. So this is also one board because this also supports the display devices. You can connect the display to create the edge analytics based application or medical based application can be created using these boards. The next one is the simplest one. It is if you even know the Python, then you can use this board for creating the algorithm based edge analytics application. So it is a simplest one. It support the Wi-Fi, Bluetooth as well as LoRa in single board. So it is cheap and it's about 2000 rupees, I think. Next one is the Spark from Edge development board. So it can be used to create similar to that of Arduino Nano. It's a cheaper one, but based on the ARM processor, you can use this also. Also, Adafruit Edge grades. It's also it comes with a small LCD, so it directly supports the TensorFlow Lite. You can use this one for edge analytics devices. Okay. These are the devices commonly we are commonly using in the edge analytics based applications or any IoT application with the edge analytics. So next one is the we need to build something. We going to build some application. First, we are going to build already we have said that there is a edge impulse device. Edge impulse platform we can use to create the edge analytics based devices. So we going to create some minimal basic level of edge analytics based application in your mobile. I think everyone has mobile, right? Everyone has smart mobile. Hello. Okay. There is we need to, if you need to work this in yourself, you need a mobile, a smart mobile, and you need a computer that with a browser. So first we need to create a login. You need to create, it's a examples, we are going to create in example application examples. So first you need to create a login. So it's the login. When login into your examples, it will be the first section. So you need to create the project. Okay, project is created. This will be the some interface of examples. The easy one. You need any coding for training and creating models for edge devices. So first one is the device. You need to create a device. You need to create. There is a main device that supporting this platform. So you can currently we are going to use the smartphone as a device because smartphone consisting of many sensors like accelerometer, gyroscope, light meter, mic, camera, etc. So we use this device as a smartphone as a device. So first we just need to share my camera. Can anyone see my camera? Hello? Okay. I am going to use a simple a smart mobile. So we work with this smart mobile to create an edge analytics based application. So first we created we are logging to the edge analytics base. So if you are able to log in, please log in fast. Then you can do the same. First need to connect the device. So we are going to connect the device. We click in the connect a new device. There are many supported ports available. If you are clicking the supported ports, there is already a listed that thing. These are all things are supported by this platform. So you can write the code directly using this platform into your device. So we are currently using your mobile as the our smart edge and click device. So showing the QR, just going to scan the QR. So I scanned my URL. So I just connected to both my mobile and my dashboard. So we can start. So it will show your mobile is connected here. So there is mobile client is available. Your sensor details there. What are sensors available? Also there is listed. So the next one is a data acquisition. So data acquisition is we need to create a project. What the type of project we need to create? Today I like to show simply picture the motion based application that our mobile is ideal or up or shaking. That the three things I like to detect using my mobile. So first data I can need to collect is the ideal. So what the sensor we are going to use? Because it's a motion based sensor we are going to use. We have three sensors available: accelerometer, microphone, and camera. We are currently using a motion based application, so we are going to create accelerometer. So getting samples. When you clicking sample, you see the mobile. The mobile have automatically collecting my data. Okay, that finished and uploaded to your dashboard. So you can see the data is here. We collect the 5 more data similar with little changes. Completed. Completed. One more. Okay, we are 3 data in same level idea. So we next data need to collect is app. To start up is this slide. I like to place my mobile in this slide. I think everyone is seeing. Start sampling. For more data with the little changes. Okay, we have 4 samples in up level. So next one is shape. This sampling. Then that one is okay. Next one is okay. One more. Now sample is completed. We have collected our sensor data. It's an accelerometer sensor. We have 3 levels. We are currently going to do a classification based genetics. So this is idea 1 and shape. So these are the 3 levels we are going to work out. We see the each data is here. We can when you click that what the data the parameters there is show the accelerometer X, Y, Z parameters. You can see that thing. So the first step is the raw data conversion. That's we are done. The next one is we need to create the features because the raw data is not we are not going to train it because if we need to create a machine learning model, we need to create the features. We need to find out the features in the data. So the features need to be trained. So next one is we need to create the impulse design. It's a accelerometer data. So we need to create a processing block because we need data is pre-processed before we are going to train it. So we need to process the data. The first one is a spatial analysis. This is a commonly used in accelerometer based application. So it can be analyze the accelerometer data and the power spectral characteristics. So to identify what going on the accelerometer data. So we use the spectral analysis data. The learning block will be we need to using the classification. There is many things available here. We are commonly using classification for this one because we have 3 levels. We need to say classification based machine learning. So we are using classification. Add it. So create the save the inputs. That's the next one. So we created the algorithm for pre-processing our data. That's the second step we need to do. Next step is we need to create generate the data. Generate the raw data. It is a raw data. From this raw data, we need to generate the features. So we going to generate. We can adjust the parameter. I am leaving that everything is. You can use any filter values, cutoff frequencies, and orders FTP, FFT length. That is depending on your application. That will be varies because already know that the data is not same. So if the data need a calibration, kindly I am giving default for that. So say the parameters, it will be process your features. So it will start to generate the feature. We are using the data density is the 1 seconds. So classes are 3-1, ideal, shake and love. Then window using 200 milliseconds is our Windows length. So window increases is 80 milliseconds, each Windows is 80 milliseconds. So training the window, we are going to train the data. So clicking the generation. It will start the process by creating automated system that will generate your feature for the data. Job is completed because the data feature is generated. You can see the data is here. Other data is here in each color, up and shake, because shake is a more vibrant data because it's a shake in one is XY is very high, so it will be the higher one. Then the other one shake and up and ideal is a simple one, so it's shown here, up and ideal. You can see the water data and size, features, everything here. Next one is we need to create a classifier. You need to create a classifier, or you need to train your model. First, we are going to evaluate classifier. So there is a classification number of train cycles. Currently, commonly is 30. And linear rate, the linear rate we are going to use. Conference rate, minimum conference rate need to obtain. And then network architecture. You can create or edit any type of any number of neurons you need because every network can different neurons or CNN are different neurons that can be set here. Currently I'm not doing anything. Leaving if you are need do or if you are doing yourself, you just experiment on this network architecture. Leaving the default. So I'm going to start the training. It will start the training. You can see that here we are using the TensorFlow Lite 32 model is the output. It will be converted into integer model, integer 8-bit model, which is the process I already told it. So currently model is training computer generated. So we can have a 72.2% of accuracy with a loss of 0.48, and there is a confusion matrix with the idea of 100% and everything only up have less accuracy. All other two level have good accuracy. You can adjust the parameter, retrain to optimize this model. You can adjust here or adjust these layers to create the vector model and leaving the normal one. You can also create the which condensation you need to use. It's a unoptimized 132 is a normal model or condensed based intake. It is already condensed by the edge inverse algorithms. So we need to retain this model. So we are going to retain that training again. Okay, that model is completed. So this model can be we can use to deploy into our mobile. So we go into the live classification section. So we are using this model for we need a data to test this model. So we need a data start sampling your data. So we are sampling data. Is a you can see the mobile is laying down. It's in ideal condition. The one data is sampled and classified. Let's see. Okay, the data is predicted as 0.5% of ideal because it is the ideal one. So it is the ideal that is the probability is higher. So that's the ideal one. We can do next data. We'll put data. This will be okay, let's classify. So it's a part 1, you already see the 6 count is there. And so I say 70% of accuracy that so next one is shape. Where is shaking that device? There is a feature, you can select the feature here because we need to classify here, it is shaking one. So there is a 72% shaking count with 100% accuracy. So because it's shaking is a good data, so it's getting 100% accuracy. So these are the live classification. You can okay, this is a live classification in our edge devices from getting the live data. So if you need to model it to deploy into your mobile, you can go to here. You can see your see my mobile. There is an interface here. You can see switch to classification mode. So I switch into classification mode. It will download your model already built in your dashboard. So that data is received 83 KB. Now when it is in live mode, you can see the live sampling and predictions there. You can see that there is a live predictions is going on your mobile. It does not need any internet in your mobile to predict that thing because already a model is downloaded into your browser, so it can be predicted in your mobile. The prediction is happening here. You can, I think everyone is seeing. Okay. Okay. This is the simplest application that I shown. That you can use this same model to deploy into your edge devices that previously I had told. So for that you need to create deployment in your dashboard. There is many options that's available here. Creating the library, because already I told that after the conversation creating model, you need to create the library to generate the embedded code for your controller. So there is a available feature is you can directly create a C-based compiler that can create a C library that generate the code, and it will create a library for that model that can be used to any C-based applications. Also, there is a Arduino support. Arduino library is available, and STM32 based available, and this is a web-based one, and NVIDIA-based applications. These are the libraries you can create. Also, you can build the framework. Directly, can build the framework for these supported devices. That if you create the framework for edge-based device for Arduino Nano 33 BLE, you can select the device. Just create build option that will generate your binary code for your devices. So that binary code only need to be write to your device. So it is easy and simple one. So if you are create a library, I'm going to create a library, simple one, creating building model. The original library will be downloaded easily. You can save it. So there is a default. There will be an example. You can use this example to connect to your any device in Arduino devices. So SRC is also available. You only need to export this library into your Arduino. Then you can program using these examples. So this model will be working your embedded devices. These are the thing we are. It's easy one. So. I think anyone need to do this thing currently. I can help. So first thing is login. Can you try everyone this application? Or any questions?
Sudesh, it was difficult to concentrate on your talk and try it out.
Okay, I do step by step. First, you need to log into your Eximburst site. I will post the link. Can you everyone log into the Eximburst site? Can you confirm?
Can you please present your screen also so that?
Okay. You just need to create a login here. You need to go to the Eximburst studio. I already put the link in the message box. You can do create a login. Can you confirm after creating logins?
Evaluation user. As an evaluation user, right?
Yes, evaluation user.
We are getting a different dashboard, I suppose.
Okay, can you share?
I don't see that make a new project option. It comes like collect data.
Can you share the screen?
Share the screen for that. Okay, one second.
Or you seeing this one?
I've shared mine. Can you see?
Okay. Okay. Okay, so already I think you are already in demo application. So just click the Eximburst home page and top Eximburst. You just click the logo, the Eximburst logo.
What logo?
You will see the Eximburst logo is like this one, the top and top side.
It's
Okay, I think you are. Did you log in with your email ID?
Yes.
Can you click the user,
Sorry.
evaluation user? Click the user icon, evaluation user icon.
Oh, here. Create new project.
Yeah. Okay, create new project. Okay. Okay. Click OK. Okay. Now you are currently your new project. So you need to connect your device first. So go to the device. You can see that say connect the device. Go to device. There is a connect a new device icon.
Connector.
New device icon in device tab. If you are going to device tab, this will be connect. Okay, I will show you my screen. Okay, now you just leave the session. I will show the steps. Can everyone see my screen? If you go into device, you can see this. Here is connect a new device. Click it. Do you see that?
Yes, connected.
Okay, connected. So just after connecting, you see the mobile is connected. In your mobile, also there is a green tick that connected to Edge Impulse. Same ID with the same ID. The next one is you need to collect the data. First, you need to collect the data. Go to the data acquisition. So if you are going to collect the data, you need to create a 3 layers. You are going to use accelerometer data. So select your device is already mobile is connected here. Device is selected. So select the create a label. Select the sensor you need to going to work out. Click start sampling and create 3 labels, 4 data for each label. Collect the data. Is everyone is doing this? Hello.
I'm trying it out, Sudesh.
Okay. All others. What's the problem? It's not able to following or any other problem.
Will this data set be catering to any public data set already available, whatever we collect now?
You can use the public data set, but currently we need lesser data to demo. So we can calculate yourself because it's only 16 data. You can also use the publicly available accelerator data if is in your hand is available with the same label or right. You can upload to data acquisition area.
Uh-huh. I think it takes taking time because 2 devices are connected.
Okay. If your device is connected, please go to the acquisition tab, then collect data. For easiness, we are currently have 3 levels: ideal, up, shade. So each level have 4 data. So you need to collect 4 data for each level by changing the label name and clicking the start samples. Also ensure the sensor is accelerometer. Sampling. is completed.
Just finished over there.
When the data acquisition is completed, you see the all data is listed here. And so you can click the data, you can see the samples plotted in your right corner. So next step will be the you need to create the filter section, because you need to data filter or data feature extraction section. So first you need to create the impulse design. So go to the impulse design. If you complete it. What about this? Is it doing?
In this design, we have to change the window size or just create output feature.
You can adjust it if you want, and just keep it the default.
There is no pre-processing.
Pre-processing, you click the pre-processing block, so it will pop up. You can click the pre-processing block. Currently, it's an accelerated one, so I select as first one.
Okay.
The next one is the classification model. So we need to create the classification is the name. Currently, I am using classification using keras. So we have select the learning block. That will be the neural classification based on keras. So click the add learning block. Select the classification model.
Okay.
So save the inverse. Next will be the save inverse. After saving that, just go to T-shapes features. Next tab. So we will see the parameters. You can adjust the parameters that already we are selected for creating your feature. So you can adjust or leave it as default.
Okay.
So same parameter. Let's go to generate feature and try to generate your features.
Yes.
Okay. After generating the feature, the next step we need to be train the data using the generator feature. So go to the NNN classifiers. That's already named. So go to classifier training section. You can adjust your training cycles, learning rate or minimum conference rate, etc. Also, you can able to adjust the number of layers in your neural networks. You can add extra layers or adjust the number of neurons that already present there. You can update the layer as you want. If you are not interested, you can leave that default. Then start training.
Okay.
What accuracy score you got?
So it's the 88.
88, okay, that's a good one. So okay, after completing that, you need to save this model. So you go to the retain model, try to train again.
Retrain model.
Next one, next tab.
So here you go on till you reach the desired accuracy, right?
Yes. So go to that model, try to retrain it.
Yes.
After completing the retraining, let's go to the live classification section. When you go to your live classification, you will see the device is already selected. The sensor is accelerometer. You can adjust your sampling length or frequency. That it must be same as when we are collecting the data. It must be same. So I think you are using default. So keep it same. So try to sample one. After collecting that data, automatically classify and will show you the predicted data in your screen. So you can what the data is coming out, what the predictions are. Can you are you able to are you able to create the classification? Hello. Hello. Okay. Someone tell the connected device. Go to the data access session after connecting the device. Create the 3 levels. Currently, I just created ideal, up and shake. Collect the data for each level for 4 samples. So someone is started. Someone had introductions. What the introduction? This is completed. Hello? Hello, am I audible?
Yes, sir.
If someone is not able to follow, please tell me so I can. Help you. Okay, I think the service completed the tested the model. So after the model is completed, you can deploy into your mobile. Just go to the mobile screen. Then in bottom you can see the switch to classification mode. There is a tag here in bottom. Switch to classification mode. So when click the switch to classification mode, it automatically build your model and download to your mobile. Can you confirm? Hello? Sir, already you are completed your live classification. So try to deploy into your mobile. Please message someone how you need any help. Hello. Hello.
Yes, sir, we can hear you.
Okay. There is no response, I think. To deploy your model into your mobile, please go to the mobile browser. There will be a option in bottom, switch it to classification mode. So just click that to download your model into your mobile. Everyone do this. If any question regarding this, please message me. Can anyone confirm that you are getting the outputs? Hello? Sir, hello? Am I audible?
Yes, sir.
The service, if it, okay, then we can wind up this session.
Okay.
Anyone have any questions?
I hope nobody has any questions.
Okay.
Shall we wind up?
If it's okay, we can wind up. You can try in yourself because it's a simple one. So the dashboard already there is a lot of document here there. So try it out. You can work out with the examples. Create some example-based applications. Also, next session you can use this to create LoRaWAN-based example application. So I think today's session we can wind up. Thank you.
Thank you, Sudhi sir. It was a very nice session because I have never come across this models, and it's a very useful tool. I think using even for demonstration in the class also we can use this tool. I think this will be very useful for each of the faculty members who are attending here. So I want to thank Sudhi sir for this sharing this information and having a hands-on class with us. Thank you, Sudhi sir. And
Okay, thank you.
I want to thank all the
Thanks for
participants.
giving me a chance to share my knowledge. If from my side is in mistake, please excuse me. Okay,
Nothing.
thank you.
So I think you can contact them. The entire ICFOS team will be available even after that if you have any clarifications to
Yes, we can make our
programming. Surely they'll be sharing the information maybe in the evening in the final session. So I want to thank all the participants also for joining. So tomorrow we will have start our session at 10 o'clock. Tomorrow we will be basically focusing on our hands-on in LoRaWAN. So kindly join at 10 a.m. tomorrow. Thank you everyone. Thank you. Thank you, Sudhi sir. I will share the feedback link also in the WhatsApp group. So kindly take time to fill up that also. Thank you.
Hello.
Yes, ma'am.
Hello, RMC.
Binu ma'am.
I think I lost my voice somewhere in between.
Ma'am, I didn't get you.
Is Sudhi sir audible? Like I was not able to hear him.
Okay, he actually winded up the session. I think he is available.
Sorry?
He winded up the session. No, he has left the meeting.
Meter? Oh, I didn't know that.
Yes.
I lost
connectivity.
Okay. By the way, will you be sharing the video recording of this, like all the sessions? Like, is it possible?
Yes.
Okay,
Yes,
that'd be greatly interesting. Yeah. Okay, I think I should also leave the meet. I'm the only person left.
No. Many are still there. Thank you. Ma'am.
Thank you. Okay.